Hello. I'm going to talk a little bit about what I consider to be the most important part of developing successful AI applications evaluation. Evaluation is a very long topic, and actually, to spend time talking about it is a very exhaustive task. So, please forgive me if this video and the subsequent videos will be a little bit longer than what I normally do. I just want to cover this very important topic. Let me start by the quote from OpenAI's co founder. Um, Evals are surprisingly often all you need. And this is very true. And I'm going to talk a little bit why is that? Why evaluations are suddenly so important? Um, Particularly when we talk about evaluating artificial intelligence model or artificial intelligence systems, we are talking about three separate things, and all three are kind of related to each other, but slightly different stories. The first type of evaluation that we are looking at is model evaluation. Today, I'm going to talk a little bit about model evaluation. How do we consider what foundation model is better or worse in performing a task or doing something that we want them to do? There is another story, of course, like any other application development. There is a story about evaluating these models when we are designing and developing the application. And there's a third story, which is in ops, like any other type of MLOps story that we had, or DevSecOps, as a matter of fact. Ops is another important story, and how do we evaluate these things continuously would be another topic that probably I need to cover in a separate video. Now, the first thing is, and the first thing is, why do we need evaluation? And I'm talking particularly about model evaluation here. Number one, and the most important reason that we need this, it's very evident, self-evident, it's ensuring the quality. And the quality is, of course, everybody can say that they need a high quality system, but what does that mean? We need to understand what does the word high quality mean? Like, to quantify this often very hard to quantify concept. Mitigating risk, figuring out what are the potential risks of a model and how can we improve it or actually mitigate them without that thing happening. And very importantly, building trust with all the stakeholders, because we transparently, and sometimes before we even offer the solution to people, we can tell them what are the areas that the system will work or will not work. So now you might say, Mohsen, why are we even talking about this? And that's a very good point. By the way, I'm following the logically. I try to follow this book, and it's a very nice book. Please, I don't know the author, but I like the way that things are organized. Um, so it's a little bit of a different take on the book, but I'm following the same steps. So you might ask, why do we need evaluation, and why is this even a topic? Because I thought from 1950s people were building machine learning and AI applications. What is so different? The reason that we require certain new tools is, number one, I think the open-ended nature of these foundation models and the new wave of AI applications. So if you are using an application that can give you a lot of different answers, so understandably, just doing these evaluations would be a bit of a tougher ask. Complexity is another story. We are using AI for tasks that are kind of new. So enhancing error detection, figuring out what's going on, it's a slightly different story here. Black box problem, I covered that before. I don't necessarily think that this is a black box problem, but at least we can agree that it's very hard to actually understand these large foundation models and figuring out why they make the decisions that they make. So therefore, actually measuring the outputs is harder because things are more stochastic, and these are autoregressive models, right? The other situation that we are finding ourselves, which is kind of new, is that no matter whatever benchmark people define, especially more traditional ones like MMLU, these larger models can quickly actually saturate them. This is a very interesting situation. And as we are going forward, there are more and more tests and evaluation mechanisms that people are creating. It seems like that models above a certain size and capability quickly saturate these capabilities and are able to basically uh, quickly give you very, very high results. And there is an investment lag as well, right? Like it doesn't look like people are investing as much as they invest in building these models. Now, there is a class of so if we talk about think about natural language generation, right, which is a kind of the story before we go to the foundation models, right? Like for many many years people were generating stuff. One of the key topics, and this is probably coming from Shannon's idea, it's very old, is can we figure out entropy of these models? Entropy is basically to figure out a metric that shows what was the confidence of the model guessing what is the next word. And alongside entropy, of course, we have something else which is called perplexity, which is kind of a little bit of a different take of entropy. The idea was that if we have a set of text that human have generated or was part of the testing set, can we measure the output and say how kind of aligned these things were, like how confident was the model to generate text based on the distribution of the real distribution that we had. If we compare them, how confident it was. This is very interesting, and historically most of the smaller models used to provide perplexity as a metric. I think recently people are not giving perplexity. There are a lot of reasons for that. One key reason that perplexity is not as important as it used to be, at least on very large models, is because what we are seeing is when we do improve these models, like let's imagine that you do reinforcement learning from human feedback or reinforcement learning from AI feedback, or whatever you do, these models actually perplexity increases. So the lower the perplexity, the lower entropy is better, right? uh, uh, Basically model is more perplexed, to put it mildly. And the reason for that is, if you think that we have trained the distribution of the training data, we had something about making a bomb, right? um, Now, of course, when we do align it with humans, we don't want our model to be able to talk about these things. So basically, what happens is we technically increase the perplexity. The model is giving stuff that is not aligned with what it has been trained on. That's a caveat, but still very useful if you are fine tuning your own model. If you are working with smaller models, I would say it is very useful to measure perplexity. So you can still use that as one of those metrics. Um, the other thing that I won't spend too much time, but I think it's very useful for many cases, especially for code generation, solving math or science problems, game playing, or task outcomes, right? Um, when we have measurable outcomes, right, that we can achieve an objective, one of the best ways of actually evaluating an AI foundation model will be to just see what kind of high quality stuff this model can generate, right? That's it. Very simple. For code generation, the good news is we were doing these things through software testing for STLC for many, many years. I work for a company that has a very, very confident way of doing these kind of things. So I can see how quickly we can measure the outcome. So basically, we consider AI model as kind of a human. We evaluate the quality of code with functional testing or whatever tests that we had. So we don't necessarily need to build stuff. The downside with these sorts of evaluation metrics, I think, is you cannot apply it for open-ended situations. That's the basic downside. The second group of exact evaluation, right, like alongside the function, are similarity metrics. You can do exact match. Nobody stops you. If you have all the answers that this chatbot needs to say, you can compare and see if it's exactly answers you like a human. You can see the problem, right? It's not fluid because it's not a chart. Like that doesn't mean anything. You can go one step further and do lexical similarity. There are n-gram ways of measuring the difference between a paragraph or bunch of words and the words that we're comparing with. The problem again is kind of similar, slightly better. But if you calculate bleu or rouge distance of this phrase with the original phrase that human have provided, it doesn't care about the semantic meaning of it. It just cares about the exact similarity between the two words. A lot of issues here. You can imagine that. So I won't go explain an obvious problem here, but n-grams are still useful if you are generating something that has a very limited dictionary, right? And you want to make sure that you're close. Very few use cases for lexical similarity used to be a lot bigger, maybe initially when the LLMs came. Now we mostly focus on semantic similarity. Semantic is the same way that we do retrieval augmented generation. We can process a baseline text and generate some embedding and then do cosine similarity or to some other similarity algorithm and see if these two are close or not. The downside, of course, is you need to have a lot of benchmark text, and that depends in your use case, but honestly takes a lot of time to create those things. But if you put that aside, I think semantic similarity is very useful, especially if you're an insurer, you work with policy documents, something that you have a lot of examples. So semantic similarity is kind of easy to do, but in many cases it's not possible. This takes us very nicely to one of the most common or better ways of doing these things, cheaper way in terms of at least time and resources, which is using an AI as a judge. I also always imagine this as two separate ways that we can do it, right? Number one, you can have a very large model looking at the outputs of small model, right? And what you do is you basically, the large model will criticize and give scores like fairness, relevance, coherence to the small model. Because the small models are easier to fine tune, you can fine tune them to more and more get more aligned with the larger models approach. We will talk about it later. The second and more interesting way, I think, is the other way around. You can have a large model randomly select, small model trained on specific type of judgment, and then look at the output of the large model and start providing feedbacks and score it, judge the output. Both cases are very useful. I think things are getting much more interesting here. Majority of actual use cases would benefit from AI as a judge. The way that you implement it can be very different. All the major platforms now have them. Criteria could be really open, so you can define what is your criteria: faithfulness, coherence, fluency. You can explain it. The larger the model that you have, the more flexibility you have. The counter argument to this is before this wave of LLMs, there were a lot of models that, for example, Facebook had to check the toxicity of the posts that people put in their network, right? Those things can still be used. So AI as a judge is a big thing. Of course, there's inconsistency. There are still autoregressive, non-deterministic models, right? I want to be very honest. They're position bias, they're verbosity bias, they're all the things that human have. I mean, maybe a little bit different, but they still have. So a human would probably prefer his or her own text over the other person. Same thing goes here. And the biggest issue is probably cost. So if I'm generating with GPT-4o and I'm asking GPT-4o to look at it, I'm technically at least doubling the cost of this test. There are different ways. You don't need to do evaluation on everything, and judges can drift as well, right? This is another story. Um, and another thing that I can say is you normally use these things in a flow. So, for example, if it's you can have kind of a funnel way of looking at it. You don't need to only use one. So in a use case, for example, in a media marketing use case, you can have AI as a judge to check brand voice. You can have semantic similarity for text quality. You can have feedback, multiple things you can use. Finally, let me talk very briefly about how to rank these models generally. This is mostly pertains to not maybe in an enterprise setting, but overall can be like the same way that we rank chess players or tennis players, we can use the same approach to actually rank these models, like OpenAI model versus Google versus another model, and then use certain algorithm to sort them around, like calculate win rates and then apply the rates to some sort of algorithm. Both of them are designed for sport commentators, right? Elo and Bradley Terry, and rank them. Hard to implement in enterprise because it requires a lot of time to judge the quality of these outputs, like n pair outputs. And it works better if you crowdsource it and you have a lot of people giving you that feedback. But the results could be very meaningful. I don't know. I'm not confident that you can do it in an enterprise setting, to be honest, because we don't have such a huge number of people who can generate these things. One good example is, of course, everybody knows this, the chatbot arena LMSys, right? And currently, as we are speaking, you can see how close the scores are. And Gemini 2.5 Pro is leading, GPT 4.0 and Grok is the third. And to be honest, very close. It's very hard to uh, be so precise with these things. Look, we covered a lot of different things. Of course, there are a lot of pros and cons, like the time consuming, the whole idea of model evaluation, resource intensive, and there's a lot of complexity. I know that, but the pros are, I think, more important here. The In order to have a reliable system, in order to be able to improve the system, and in order to make sure that our system is safe to use, in especially for critical workloads like customer facing situation, I don't think there's anything around it. I'll talk about other types of evaluation as well. Like model evaluation can comes into many parts of building these systems, like model fine tuning and training. I'm going to spend some time probably in future talking about system AI system evaluations and AI operations evaluations for that as well. I think I covered the operational evaluation in a course that I published in December. But yeah, thank you very much for spending time with me, and yeah, enjoy the rest of your day.